So we're going to tackle something that's actually really tricky, and that's determining whether or not what signs enthalpy and entropy have. But in order to do that, you need to realize there's one equation that determines everything in this world, and that's the Gibbs free energy equation. It's the change in G of the reaction, and it's at standard conditions, is equal to the change in H of the reaction minus T change in S of the reaction. Now, the two variables that we're really looking at right here that we care about are enthalpy and entropy. Now, if both of the conditions are good, and I say good meaning want the reaction to go forward, then the reaction will go every single time. If both the conditions are bad, in other words, neither of them wants the reaction to go forward, then it'll never go. And when I say the reaction goes forward, Alex uses the word spontaneity. The College Board uses the term thermodynamically favorable. So when we take a look at this, I'm gonna do something that will help you with this, but I don't know whether or not you ever want to write this down on an actual exam. But what makes the reaction happy and go is we want to have a change in H that is negative. We want an exothermic reaction. We want to lose energy, and we want to have a change in S that is positive. We want to be more disordered. Now, I failed to put the S and the RXN, and there's some purists that will look at that and think that's not great. But every single time you have a negative change in enthalpy and a positive enthalpy change, the reaction will go. And if you're into the weeds and you're like a chemophile, you love doing this sort of stuff, reaction will go anytime that you have a negative change in G. So you can plug the values in here if you want to see the reaction go, but I'm going to go with the good and bad here. And again, let's say if we wanted the reaction to never go, we want to have our change in enthalpy be positive, an endothermic reaction, and we want our change in entropy to be negative. So let's take a look at the actual problems and see what we're going to do here. So when they say this, and they say that the reaction is spontaneous only above 71, that's telling you that the temperature is going to impact whether the reaction goes. But then they add this little disclaimer, and I'm going to put a line right through it that's going to disappear in a second. But when they tell you the speed of the reaction, it has nothing to do with whether or not the reaction goes. This is a kinetics problem right here. They've just thrown in there as a distractor. So what we do know, though, and we look up here at our equation, is that this T right here is tied to our S. In other words, if our T gets bigger, the S, this overall expression, becomes more important. If our T gets really small, this entropy, no matter what it is, becomes less significant. So when we look at this, it says this: the reaction is spontaneous only above 71. So that means that above, as the temperature goes up, the reaction goes. And it means additionally, if the temperature goes down below 71, the reaction stops. That must mean that the S is determining whether or not the reaction goes or not. If it goes up, the reaction goes. That means that the entropy must be good for us. In other words, we're dealing with a positive entropy over here. Now, simultaneously, if it goes down, then the H becomes more important, and the H determines the reaction doesn't go. So when we write this out, we're gonna say that change in S is positive, that's a good thing, and the change in H is negative, which is not a good thing. So let's look at the next one. And again, they all kind of play the same game. If they say the reaction is always spontaneous, always, we don't care what else they talk about. This is all bananas. It doesn't matter. So we take a look over at our what matters here for happiness. If you take a look over here, if we have a negative change in enthalpy and a positive change in entropy, the reaction will go every single time. So we are going to very happily write over here a negative change in enthalpy and a positive entropy change. Now, hopefully you're following along with me here. I'm going to change color here so it makes it a little bit different. If the reaction is endothermic, what that's just telling us is something about our change in H. Endothermic means that we are gaining energy, so our sign for enthalpy is going to be a positive. Now, here's the thing. That's all they told us. And aren't there two conditions that determine whether or not a reaction goes, both whether it's exothermic or endothermic, but also what about the entropy? Did they say anything about that here? Not at all. So since they don't tell us anything on here, and I don't have the ability to scroll down on this, We don't know it, so it's unknown. Hopefully this has been helpful for you, and don't get too discouraged if you start flipping them back and forth in your head. I would come back over to this part right here and just realize if you can think in terms of happy and unhappy for the reactions, then your signs will work. You might want to just jot this down on the side while you're doing the problem. Hopefully this helped.